Hello guys, I just decided to record a short video and at least how to measure the equivalent resistors. Since here in the lab, so I will use the measurement instead to use the current and voltage. So let's start with the first circuit that we have. So this is the circuit that we have. So we have a couple of the resistors. They are connected together. If you wanted to find out how much the equivalent resistors, I have to identify where the place. So here I draw it here in the piece of paper. So I wanted to find the equivalent resistance between those terminals. Here is the A and here is the B. So I will look in this directions here. Let's try to calculate it first to find here is the R total. So here, if you go from here and then divide two sections, I end up with the 8K series with the 4K, the R12, and those 12 here, one resistance 12, parallel with the 6K. So the new shape, it should be looks like, so let's just draw our resistance here. Here is the 2, and here is the 6K, and here is what do you have right now, the equivalent resistance first value, which is 12K, and here is 6K, and here is the 2K. Okay, I'm still looking on this side. So the next one, those two resistors, they are in parallel, which series with this one. So if you find out the equivalent resistance for this value here, it will be 12 times 6K divided by 18 by the addition. So you end up this one 4 kilo ohm. So this is the 4 ohm series with this one. So basically we find out the equivalent resistors. In that case, it will be, here is the A and B still, and here is the RT. Here is the A and B, and here we have 6 kilo ohm. Okay, that's the calculations. Now let's go to the experimental here. So here's we have a couple of the resistors. We have 2, 6, and 8, and 4. And when I came to the lab, I don't have all the resistance in my package here. Okay. So what I did, I used the property for the series connections and parallel connection to create the equivalent resistors. For example, let's go for the first resistors here. I have 6K. I don't have in my list 6K. What I did, I add two resistors in series. Here is the list what I get out. Here is the 6K. I have 15 kilo ohm and 10 kilo ohm. I connected, they are in parallel, so I end up with the 6K. So here is I connected 6K. So I have those two resistors, they are in parallel. Those two resistors in parallel. If I want to measure the resistors, in that case, between those two values, and here is the value that we got. So it's close enough for 6K. Okay, so I use the parallel connections. Similarly, for another value for the 8, I use two resistors. Here is 6,800 with 1.2K in series. So here is the 8K. So if I made connection between this one, so this 2K, and this one 6.8K. So I measure this value here. I should get the value close to the 8K. The last resistors, we have 4K. I just use the two resistors. Each one has 2K. 2K plus 2K in series. Together you end up with the close to the 4K. So I connected all my resistors or my circuit. So that's the shape that we have. So this is the 2 amps, that's the starting point. And here is the connected with the 8 amps, 4 amps, and here is the 6 amp in parallel. So the last part in my circuit, I'm talking about this part, guys, just to make it sure exactly. I take from the out 4K connected to this point here. So this is the first one from the 4K. I will connect it to this one in 6K. So here is my connections. I will use the wire to connect that. Now I am able to connect my resistors again from A to B. That's 2 points. So the first point A, this point here. The B is the second part from the 6K. It's supposed to be this point. So I will use my digital multimeter and to find out my equivalent resistors. So I can find my equivalent resistance immediately by the measurement. And in your case for the simulations, similarly, just you need to find out the current and you have the VC, so you can use the R total by dividing the voltage divided by current. Okay, thank you so much, guys.